All right, hey everybody. So day one, I think it's day one of 5 days, and you only got to work. Oh crap! This is supposed to be a day five down here. Pretend there's a day five. Um, Day two is the word problem stuff, so you don't need to know that for your quiz, but you're gonna have to know day one, day three, day four, day five. Um, I'll probably just go through day one and day two in this video. Again, you guys will probably skip the day two stuff because it's not on the quiz. That's fine. If you want to do that, that's fine. But I'm going to go over some of the word problem stuff anyway, just in case anyone's curious. So off we go. So maybe you remember this. This is from a while ago. We were solving rational equations. I think most everybody felt fine with this, but we'll go through it anyway. We said the easiest way to solve one of these equations was just multiply through by the LCD. An x minus 5 and a 5 plus x and an x. Those are all different factors. So we do need to multiply through rats. We do need to multiply through by x and x minus 5 and the 5 plus x, aka x plus 5. You can just switch those terms if you want to make it make more sense. But we're going to distribute that under the entire equation. So 4 over x minus 5 minus 2 over x plus 5 equals 2 over x. So again, when you distribute, the denominator will cancel at least one of the factors of your LCD, and then you'll just end up with the numerator multiplied by whichever factors did not cancel. So we see when we first multiply, it's the x minus 5's that cancel, so we'll end up with a 4 times the x times the x plus 5. When we multiply into the second, and be careful with the minus sign, remember the minus will have to distribute onto everything, but we're going to get the negative 2 times the x minus 5. And then this LCD does have to distribute all the way to the other side of the equation, and then you have a 2 times the x minus 5, x plus 5. But so now all of our denominators are gone. So to solve for this, we just expand everything. So here, basically, just put the 4x together, distribute it. You'll get 4x squared plus 20x. Here you're distributing the negative 2x. So you'll get minus 2x squared and plus 10x. And here, this, of course, is x squared minus 25. So just imagine distributing your 2 onto that. You get 2x squared minus 50. It still seems like an alright idea to color code things. So we've got a quadratic term, quadratic term, quadratic term, linear term, linear term, and then a lonely constant right there. So combining like terms, we're going to have, what, 2x squared, but then we're going to subtract 2x squareds. So all the quadratic terms cancel. Then we have 30x equals negative 50. I guess that's right. So x equals negative 5/3. That's what I'm getting. Oops, boxed it up too early because I wanted you to give me your answer as a solution set. So you'll say x is an element of the set that contains negative 5/3. And we're supposed to check to see if that solution is extraneous, but we know it's not. The only values that would have been extraneous were positive 5, negative 5, and 0. And we didn't get that. So this should be the one and only solution. Okay, yeah, just to show you, I went ahead and graphed this thing so you guys could see, but a good way to check your math is just to graph the left-hand side of the equation and the right-hand side of the equation as two separate functions, and then you can click and you can look and see where they intersect. So I could zoom way in on that. We see that's the one and only point of intersection, and when you click on it, you're getting negative 1.66666. That is in fact negative 5/3. So we know that we had the right answer. And then we can go back to business. Where's the me? Where's the me? Oh, right. No, wrong. Not cut out for this. Okay, did it. There I am. All right. So let's do another one. Number 2, I suppose. And I need to make room. So clear everything. Start again. All right, so we're doing number 2 this time. Put that there. This one looks easier to me. Our LCD should just be x times x minus 1. And so as we distribute that, what's going to happen? The x minus 1 will cancel. We'll just get 4 times x. Then the x cancels. We'll get 3 times the x minus 1. Then the negative 3 will get hit by the whole thing, the x and the x minus 1. And then the whole equation will equal 0. So there's everything that I would have after multiplying through. I'm not showing any of the work. You guys will show the work, right? Because you have to. But that's where I'm getting. And from there we just expand everything and combine like terms. So I'm looking at a 4x. That was ugly. And a 3x minus 3 and a negative 3x squared plus 3x equals 0. Alright, so I've got this 3x squared. That's telling me that I want to kick everything to the other side because I want a positive leading coefficient. So how many x's do I have? 4, 7, 10? And they're all positive, so when I subtract that from both sides, I'll have minus 10x. Then the only constant is that 3? Yeah, sounds right. So I'll add that and I'll get plus 3. And this quadratic is factorable because 3 times 3 is 9. And for factors of 9, I can use 1 and 9 and I'll get the 10. So this thing is going to be a 3x and an x. I want factors that are 1 and 9, so I should put a 1 here and a 3 here. Now my outer product will be 9, my inner product will be 1, and as long as I make them both negative, I'll be getting a negative 10x as my middle term. So there's my correctly factored answer, and I can see that my solutions are going to be positive a third, which is not extraneous, because the only extraneous values would have been positive 1 and 0. My other solution is positive 3, which is not extraneous. So we'll say x is an element of the set containing both of those. Those are both zeros of this function, or solutions to the equation. So there, those are my solutions. Moving on. All right, so I'm now figuring out we can only fit one of these per page, which is fine. So this will be the page for 3. So we'll wipe that out, buy myself some more room. All right, this one looks kind of like a pain in the butt. Looks like we'll be multiplying through by all of that. I'm going to need that factor of 3. I'm going to need a 3y minus 2, and I'm going to need a y minus 1. And we're going to just multiply this whole equation by this LCD. So distributing that in, I'll get 3 and a y minus 1 multiplied by my numerator, the y plus 2. Then the second term, I'll get the 3 and the y from the numerator. And the y minus 1 will cancel, so I'll still have a 3y minus 2. Then when I distribute onto here, it's only the 3 that cancels. So I'll have a 2 and a 3y minus 2 and a y minus 1. So there's everything. Now we just have to expand. So what's this going to be? Y squared plus 1y minus 2. And we'll distribute a 3 onto that to get 3y squared plus 3y minus 6. Here we're distributing 3y, so we'll get 9y squared minus 6y. Then this is 3y squared minus 3y minus 2y, so our middle term will be minus 5y, and our last term will be plus 2. And we're going to distribute a 2 onto that, so we'll get 6y squared minus 10y plus 4. So there's everything. I think I do want to run my highlighter again. So I've got quadratic, 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 linear, 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 and constant, constant. Okay, so what do we got? We've got 12y squareds over here on the left and 6y squareds over here on the right. So we'll pull everything to the left, and 12 take away those 6 will leave us with 6y squared. Then we've got negative 3y, but we're going to add 10, so we'll get positive 7y. Then we've got negative 6, we're going to take away 4 more, so our constant will be negative 10, and this is all going to equal 0. I'm not loving this, but let's see how this goes. We're going to have negative 60, and we're looking for factors that give 7. It's not sounding super promising. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. Okay, 5 and 12 does it. So we would want the 12 to be positive, the 5 to be negative. There you go. Again, there's no, I don't have a lot of pride anyway, so guessing the right pair of factors on my first try, that's not my thing. Just work methodically. Just do the 1 and the 60, then go to 2, 3, 4. Just keep running through the list systematically. You'll find it eventually, or you won't. If you don't find factors that work, but you worked systematically, then you know you haven't missed it. You know that you really just can't factor, and then you have to use quadratic formula. Alright, so anyway, factoring this, I don't know if we've seen this. I know at least one class saw this. But now if you're trying to factor this using my trick, then you don't really know yet whether this is going to be 6y with a y or a 3y with a 2y. And the answer is, well, it kind of depends on your factors. If you want to get a factor of 5 though, then there's no integer value times 3 that'll make 5. And there's no integer value times 2 that makes 5 either. So that kind of tells you that this is not the right pair. And you do want to go with the 6y and the y. So 6y and y. Because then I know that to get the positive 12, I just need a plus 2 here. And that'll give me an outer product of 12. Then the inner product, I need the negative 5. But there's my factored form. Not sure why I'm putting a box around it. A little too early for that. But we still don't have an extraneous solution? No, we don't. For solutions, I'm seeing y equals negative 2. And that's not extraneous because it's not a 0 of either denominator. And my other 0 is positive 5/6. Really, that's the thing you should be boxing up. That's your solution set. That's the answer. I'm going to take that other box away. That was a mistake. That's just part of our work. Don't put a box around that. But there's your answer to number 3. So 4 then. Let's just do this. Where's the arrow? There it is. Okay. So for number 4, this doesn't look too bad. I think I did this one in class for both classes. The toughest thing about this was I think there were some people who were thinking that b squared and b were sort of different and that you needed both as part of your LCD, but you don't. We talked about how you just need the one with the greatest power is all you need. Another way of thinking about it is this is a b times a b. That's a b, and this is a 2 times a b. So if we grab one of every factor, then I do need a b, and this wouldn't cancel unless I was multiplying through by 2 b's. So you need, b squared. but the b squared is enough to cancel this denominator, so you don't need more. You don't need a third b. Now in this denominator I do need a factor of 2 to cancel out the 2, but again that b will be canceled by the b squared. So we can see that our LCD is just 2b squared, and from there we can go to town. So distributing this, I would just get a b. I would just get a 2, I'm sorry. The b squareds cancel, you're just distributing a 2, and I'm just going to do that right now. 2b squared minus 2b minus 12. Then here, the b cancels, but you're still distributing a 2b onto this. This one maybe I won't do because of the negative. So we're going to have negative 2b distributing onto 2b plus 12. And I'll do that separately to make sure I don't blow anything with the negative signs. Here, the 2 cancels and one of the b's cancels, so we're distributing a b onto that. That'll be b squared minus 39b. Alright, so just to be safe, I guess, rather than sorry, we're distributing this now, and this will be minus 4b squared minus 24b. And then the rest, just bring it down. All right, can I do this without color coding everything? I bet I can. So on the left-hand side, I have negative 2b squared. So I would add that. And over here on the right, I'll have positive 3b squared. That means everything else is getting pushed to the right. So I've got negative 2, so negative 26. We're going to add that. That'll leave us with negative 13 b's. And we've got a constant. We've got the 12. That's it. Yeah, so we just add 12. And that whole thing equals 0. So that's the quadratic now that we want to factor. And so we'll be looking at factors of positive 36. Trying to get a 13. So that's 4 and 9. Negative 4, negative 9, because we want it to be negative. So I guess we're going 3b and b. To get this factor of 9 or negative 9, we'll need a negative 3 in this position. Then our outer product will be negative 9b. To get the negative 4, we'll go minus 4. Still no extraneous solutions. We'll just say b is an element of the set that contains. I think this whole homework maybe had no extraneous solutions. You guys know that your quiz probably will. So we get positive 4/3. We get positive 3. Neither is extraneous. And you guys are working on making decent looking braces, right? No more just haphazard squiggles. Okay, you guys can do it right. Let's do 5. Haven't duplicate. Oh, there's 8 of these? Oh man, for some reason I thought I was done at 6. Okay, I don't think I need to do all these, but if somebody out there is watching it all, then God bless you. Alright, so for this, what's our LCD? It's going to be the x plus 3. It's going to be an x plus 2. We're also going to need a factor of 6. So there's your LCD, those 3 factors. We're going to distribute that. And the same thing that always happens is going to happen. Somebody's going to cancel. In this case, it's the x plus 3. So we end up with an x plus 1 times the x plus 2, and also times a factor of 6. Then the next one, the x plus 2's cancel. So we end up with a factor of x minus 5 and a factor of x plus 3 and a factor of 6. And then over here, it's only the 6's that cancel. So we get 17 times x plus 3 and x plus 2. Okay. So this is what? X squared plus 3x plus 2. You're distributing a 6 onto that, so you'll get 6x squared plus 18x plus 12. This is x squared minus 5 plus 3, so minus 2x minus 15. Now you're distributing a negative 6 onto that, so remember to change all the signs. So it'll be minus 6x squared and plus 12x and plus 90. And over here, x squared plus 5x plus 6. We're distributing a 17 onto that, annoyingly. So 17x squared plus 85x plus 60 and 42 is 102. All right. I'm going to go ahead and use my trusty highlighter. Quadratic. Oh, those cancel. That's convenient. Okay. Something else that of course you could do that I haven't been doing is just clean up each side and then kind of work from there. Let these things cancel. Then your two linear terms make 30x. And these make 100. Oh, 102. Well, that's convenient. So that equals 17x squared plus 85x plus 102. So now things are just a little simpler. We can see that the 102s will cancel if we subtract them from both sides. And I guess we want to get this set equal to 0, so I'll subtract these, leave the 17x squareds where they are. So we'll have 0 equals 17x squared. We're subtracting 30, so 55x. All right, when you don't have a constant, then you just factor out your greatest common factor, which is the x. So you have 0 equals x times 17x plus 55. And then from there we see that our two zeros are 0 itself and then negative 55/17. And neither one of those is extraneous? Nope. So that's it. I don't feel super good about 55/17, but I'm sure it's right. Right. Maybe we could double check that one. Okay. So here this is again. You can see I've graphed the left side of the equation. We're setting it equal to the right side of the equation, which is just a constant, so it's just a horizontal line. But you can see the only 2 points of intersection are right there. And I don't know what 55/17 is, so you can just type that in. It's negative 3.235. And we can see that, yep, that's what we're getting there. And we do see the other point of intersection at 0. So our math was right. Those were the two correct solutions. Again, you don't ever have to check anything. I'm just modeling how you would check if you wanted to. So let's go back. There we go. Okay, so now we're doing 6. So there's 6. And you know, we're going to just do more of the same. We're going to multiply through by our LCD. And looking at this, we do need a factor first. Just to make sure we recognize that here when you factor out an m, you get m plus 1, which means I don't need another whole factor of m plus 1. Our LCD is just going to be an m times an m plus 1, and multiplying through by that will get everything to cancel. So this one looks like it's going to be an easy one because, oops. When we multiply through, we see the entire denominator of this first term will cancel. You'll just get the m plus 5. Then here, the entire denominator will cancel again. You'll just get 1. And here, the m plus 1 cancels. So the only thing left is we're multiplying through by m. Just don't miss your negative. We're basically distributing through a negative m. So we get minus m squared plus 6m. But then from here, this looks straightforward to me. I would add the m squared I would subtract the 6m, so we'll have minus 5m. And we'll subtract the 1, so we'll have 4, so plus 4. Yeah. And then that, that's it. Just factor that thing and you'll get your answers. So this will be an m minus 4 and an m minus 1. And yet again, neither solution is extraneous. So you can just give me a solution set that contains both the 1 and the 4. That's it. Alright, that's 6. Let's do 7 and then hopefully we can get to 8 and be done because I'm getting sick of this. Duplicate. Throw that in the bin. There's 8. And there's 7. Okay. Same old. My LCD is just going to be P minus 4. And maybe I was running out of ideas because these seem to be getting easier. Distributing this in, everything cancels except for the 1. Distributing onto the 1, nothing cancels. You get the whole P times P minus 4. And distributing onto this, the P's cancel, but we'll still have a P minus 6 and a P minus 4. Make sure you put parentheses around this. I have seen some people, they only distribute the minus 6 because they don't put the parentheses. They just kind of write it like this. And then, I don't know, then they do this side and they forget that they should be doing binomial times binomial. So all they do is distribute the negative 6. That's obviously an issue. Don't do that. There should be parentheses. Okay, so I'm getting a 1 plus p squared minus 4p. It is equal to p squared minus 6 minus 4, so minus 10p, and then plus 24. Okay, no big whoop. Seems like an easy one because if we subtract p squared from both sides, they cancel. So we don't even have a quadratic, we just have a linear equation here. So adding your 10p will give you 6p, and subtracting 24 will give you negative 23. Yeah, it seems right. That equals 0. So just add 23, divide by 6. And that is not extraneous. So P is an element of the set that contains. This is another one where the answer is ugly enough that I would probably double check this work in Desmos. I just don't feel like it right now, so I'm not gonna. I think that's right. So moving on, let's do 8. Great. I can't factor this, otherwise I would. So it is looking like I'm going to need a factor of 4, I'm going to need a factor of 2, and I'm going to need a factor of 3x minus 14. All of that's in my LCD if I want to get everything to cancel. So that means if I distribute here, the 4 will cancel, but I'll get my factor of 2, I'll get the x plus 7 from the numerator, and I'll get a factor of 3x minus 14. Okay. When I distribute over here, only the 2 cancels, so I'll have a factor of 4. I'll get the x plus 1 from the numerator, and I'll get the 3x minus 14. Then you distribute onto this, and the 3x minus 14 cancels, so you just get the factor of 4 and the factor of 2, so essentially an 8 times the 5 minus x. So there's everything. This is the big behemoth we get after distributing our LCD. So now we just expand everything. This is going to be a 3x squared. A 21 and a minus 14 is a plus 7x in the middle. And this is 98. We're distributing 2 onto that. So 6x squared plus 14x minus 196. Okay, super cool. This is going to be 3x squared 3 minus 14. So negative 11x in the middle. And a minus 14. We're distributing 4 under that. This is going to be one of those problems I just quit. I don't feel like doing this. I'll go as far as I can. Distributing negative 4, we get minus 12x squared. We get plus 44x. And then we get plus 64. Alright, that wasn't so bad. Then this is going to be 40 minus 8x. Alright, these numbers are larger than I typically like. There's this quadratic, there's a quadratic. That's it. Linear, 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 and a constant, and a constant. Okay, so actually, when I combine these, I'll have a negative, I'll have negative 6x squared, so I am going to want to add that to the other side to have a positive 6x squared. That means everything else is going to come to the right as well. So we've got what? 58 x's. We're going to be subtracting 58 x's, so we'll have negative 58 means 66. 58, yeah. Okay, cool. Then we have, I don't even know, 19664. 132. So negative 132, but I'm adding it, so I'll have positive 142. I mean 172. 7, 8, 9, 10, and that's not divisible by 6. Okay, and there's no way I'm doing this. I'm not doing this. How do you factor this? I'm not doing it. I'm not doing it. No one cares. You don't care. X is an element of the set that contains some crap. I don't care. Alright, moving on. Obviously, if you want to just turn off the video at this point, you may. I said I would do some of the word problems, so I think I still will. And any of you guys that care enough, you could just watch and make sure you understand word problems. I don't know if they'll ever come up, if they'll be relevant in calculus or whatever. It is. It sort of is. Being able to do word problems is always relevant. Alright. So the acid mixture problem is the one that we actually did cover pretty well in class, and they're showing you the formula anyway. So all they have, maybe I don't want to do these, because I'd have to show you guys how to walk through everything on the calculator and stuff. I don't think I want to do that. Break even. I talked about this problem in class with period 8. This one does say solve algebraically. You know what though? I don't think anyone will watch this. It'll be a waste of my time if I do this. Yeah. So it's fine. I'll do some word problems if you guys request it. Okay. You can either ask me in class or, put a comment down in the comments. But seriously, if I see a comment or if somebody asks me to go over these, then I will. Other than that, let's not worry about it. I'm going to stop this video. It's only 33 minutes, but we'll stop here, and I'll make another video for day 3. I'll probably split everything into one video at a time. Anyway, hopefully this was helpful. I'll talk to you later. Bye.